So hello everyone. Today we are going to see what is today's daily lead code problem. So this is problem number 3761. Minimum absolute distance between mirror pairs. Okay. So what the question state like problem statement says, you are given an integer array nums. A mirror pair is a pair of indices ij such that ij are in the bound and ij are like I less than j, and reverse of nums of I equals to nums of j. Okay, where reverse of x denotes the integer formed by reversing the digit of x. Leading zeros are omitted after reversing. For example, reverse of 1 to 0 is 2 1. Okay, return the minimum absolute distance between the indices of any mirror pair. The absolute distance between indices I and j is absolute of I minus j. If no mirror pair exists, return -1. Okay, so limit is also good. So what can be like what is our idea? First of all, we can do brute force, like we can use two loop I and j, and we can check like here. First write the brute force here, nums dot size. Now we will do int I plus 1 less than int I plus plus, and j j is greater than I, so j plus plus. And whatever it says, if like reverse of nums of I, so we will write our own reverse function which will like reverse the number, uh, reverse of nums of I equal to nums of j, then answer equal to minimum of answer comma j minus I. And let's initialize answer with n. So okay, if no mirror pair exists, return -1. Okay, so if the answer is n, that means no pair, we have not found any pair yet, so we will return -1, otherwise we will return answer. Now we will write the this reverse function. So int reverse int n. So how to reverse a number? Like we will just initialize the number with 0. Now we will extract the digit from the numbers and we will form it like reverse equal to 10 into reverse. First we will multiply this by 10 and we will add the digit, and then n by equal to 10. Like we if we have like 1 2 3 as a number, so first we will extract 3. So reverse, like reverse was 0 before, now reverse will be 0 into 10, which is 0 plus 3, which will basically 3. Then we will extract 2 from here. So first it will multiplied by 0, it will become 30, and we will add 2 to this. So it will become 32. Next it will multiply by 0 and we will take 1 from here and add here. So from 1 to 3 it will become 3 to 1. So this is the method. And lastly we will return reverse. Another thing you can do, like you convert the number into string, then reverse the string and convert it back to the number, uh, like string number equal to string n. First we converted this number into string, then we will reverse this, reverse this number, and we will return stoi, means string to integer. This also works, but let's comment this out. For now we will use this method. So this should work. Let's run it on the sample. This is basic brute force. So if we submit this, it will definitely give us the time limit exceeded. Sorry. Because yeah, it got TLE. because the limit here is 10 to the power 5. If we are using two loops, it will take like n square time, so it will obvious give daily. So what can be better approach for that? We can Another better approach will be like we are getting this reverse of I. Let's say this, so we have to find like what is the closest this number belong in the array after I. So we can use binary search, like we will store the indices of the for each value. Then we will just use upper bound for this I, searching the number. Like what will be our idea? Like our idea will be for every element we will store all the occurrences for it. Like for 12, like here all the elements are unique, so we will store them. But like if there are multiple occurrences, we will store that, and then we will use a binary search that what is the like closest uh, bigger indices than I. So the time complexity for that will be like n log n. So what can be the for that, like this is n square approach. So now we are going to optimize this to n log n. Like how we can do this? We will take a map and vector int. Uh, so index. Like what will this will store? This map will store all the indices of any particular element. So for each I, first of all, we will store all the occurrence of the values, like index of nums of I dot pushback I. So what we are doing here? Here we have just simply uh, stored all the occurrences for this for an particular element. Now we will go on each element and we will find our reverse of for a number, reverse of nums of I. Let's name this as target. So we have to find this. So what is the like what will be the optimal j? The basically there may be so many indices j for which like let's take an example. Like the array is something like 2 3 4 5 2 3 2 3 5 6 and 2 3, and here we have like 3 2. So the map will store like 3 2 in the zero indices only, and 2 3 in indices 1 2 3. So 1 comma 3 comma 4 comma 6 comma 4 comma 6, right? 0 1 2 3 4, and here we go 5 6 and 7. Okay. So 32 occur only in indices 0, 23 occur in this 0, sorry, here it go, here, okay. So fine, and also there will be like 56 occur in index 5. So this will be our map. Now we will traverse, like we are here 32, we will reverse this and we will get 23. So now our target is 23. We have to find that we have to find the indexes j such that the value of j is 23, and we have to minimize like I minus j absolute of it. So it is always optimal to find the next j which is basically equal to target. So here we are currently at zero index, so we have to find like in the indices list of 23 what is the just what is the smallest element which is bigger than current indices. So we can use a binary search here, like for 0, if we found like which element is just bigger than this, we will found it is 1. So here what we can do, we have to just find the indices. So we will use upper bound here and just upper bound. Now if index, if index does not contain this target, like if index does not contains this target, then we will simply continue. Okay, now we know that index contain the target, so we will go for index from target comma I. So this will be our upper bound. Now if it equal to index of target dot end, means there is no greater element than current indices, uh, till we will do continue, because we don't uh, exists no such j, and otherwise we will minimize the answer equal to minimum of answer comma like star it, which is the value of the index and current index. So this should also work. Mm, what is the problem here? A use of undeclared range of a vector. Okay. Yeah, if I submit this, this should pass, because the time complexity here is like n log n, because we're uh, we are using a map. Uh, this is also like cost logarithmic time complexity, and also use a binary search here. So you can say it is like log n kind of time. So this is slightly optimal than the previous one, like basic brute force. Now can we optimize this further? Like if you see carefully, uh, like in this indices list, what we need, we just need the element which is uh, the smallest element which is bigger than current indices. So if we traverse from backward and just trace the like latest indices of the values, like for 23, when we are here, the latest indices means recently we have seen 23 like nowhere, then here we have seen recently 23 at 6, like how that will behave. Like if I iterate over this, like initially the map is empty here for here. Now if when we will come here, what we will see, we will have seen 23, so we will store that 23 have appeared recently at index 6. Now here we will trace that 23 like 56 has appeared in index 5. So whenever we will here, we will get a target of 23, and the 23 will update like the recent occurrence of 23 is at index 1, so it will get the answer. So what we can do, like instead of storing all the indices, we can just uh, name this like recent index, like the recent index in which it occurred. And now we will traverse from backward, and why we traverse from backward, like for a particular index I we are finding j, like what is the optimal j. So for that we need to like know all the values in the right hand side to find such j. So that's why we are traversing this from back to front. Now here we got our target, and like if recent index, if recent, sorry, here If recent index does not contain target, then we want to do anything. Otherwise, like if it contains this, we will do just we will calculate the answer. Answer equal to minimum of answer comma recent index of target minus I, and then we will update the current value, uh, recent index of nums of I equal to I. Okay, so it should work. Let's run on the sample. Yeah, it works. Let's submit this. Yeah. So what is the time complexity for this? Here we are just traversing linearly and query in the map. So this map takes logarithmic time, so it is n log n. But if we declare this as a hash map, unordered map here, so then it will offer us the operation in constant time. So in that case, this whole thing will be linear. So let's submit this. So now we are basically uh, traversing this in linear time, and this reverse function takes order of d time, like d is the number of digit in the array, so the time complexity will be n cross d. So n is the size of the array and d is the like number of digit in the numbers. So these are the three approaches we can use. Like first we can use basic brute force, then we can use binary search and optimize this slightly, and here it is the like final optimization to make this kind of linear time complexity. So that's all for today. Let us let me know in the comment like which approach you have thought first and how did you solve this. Thank you for today.